Thank you, everybody, for joining us for today's webinar. It's going to be talking about our State of Attack Path Management report. We will share links. I think we've already shared links in the chat for where you can go to download the report. We think that this is a really good opportunity for us to share kind of our perspective about attack path management or attack paths in general, kind of sharing different perspectives from throughout the team. Today, we're going to be looking at attack path management through the lens. We're going to talk about some of the sections. I will be talking kind of more theoretically about what attack paths are, how they work. Alad will also kind of contribute to what situations create attack paths and what you can do about them. He will also talk about some of our efforts to extend the BloodHound graph and bring in a better representation of the overarching kind of attack landscape. And then Andrew will kind of share some of the stories from the field. So what we execute. If you go to the next slide, Alad. I think I have control, right?
Yes.
Oh, sorry. Go back one. Sorry.
Yep.
So at SpecterOps, we kind of have multiple pillars that we like to execute. A lot of you are familiar with BloodHound Community Edition, for instance. This is our product our open source product that allows us to kind of represent the attack path landscape for people. It's really useful for kind of understanding how an attacker sees your environment and how they're able to move from point A, maybe a phished user, to their ultimate destination. We also have kind of a consulting practice that primarily focuses on red team exercises, but also program development and training. And Andrew's going to share some of our experiences from the field and the types of attack paths that we're encountering out there. We think that is a really important feature of our business for really making the BloodHound, both open source and the enterprise version, as successful as they are. And part of that is because we want to be in tune with kind of what's actually out there. And our consulting services division allows us to really get an idea for what are the problems that people are facing in their environments on a day-to-day basis. And then, of course, we have BloodHound Enterprise, which is our overarching enterprise product that helps you take some of those insights from the open source product, the open source BloodHound implementation, and really start to build out this capability that allows you to manage those attack paths. How do you start to prioritize which attack paths represent the greatest risk to your organization, and how do you start to remediate those or control those and start to build different security strategies around them. I'm going to try to change the slide. Alad's presenting the slides. We practiced my ability to control. There we go. Cool. So in this presentation, we're going to talk about kind of the inherent relationship between identity and attack path management. So we've started to call this identity attack path management and kind of combine those two kind of paradigms together. We're going to talk about the difference between an access graph and an attack graph. We like to think that BloodHound is really focused on attack graphs, and we'll kind of talk about what the distinction is there. We're going to talk about a new paradigm that we've started to kind of talk about, which is identity at rest versus identity in transit. We'll talk about what we think is the most important component of your attack graph, which are these hybrid attack paths. And that's going to go into some of the different ways that we've expanded the graph in the recent year. And we'll talk about NTLM relay attacks. This is a attacker tradecraft that has been ubiquitous ever since I got into information security. But traditionally, we haven't had a good way to kind of see what's going on there and see how big of a problem that is in our environment. And this allows you to kind of view that at an enterprise-wide scale. We'll talk about a new capability in BloodHound Community Edition and BloodHound Enterprise called Open Graph. And then we'll also interlace some war stories from our consulting services, our red team operations throughout to kind of really hammer home some of these ideas. And with that, I'll pass it to Alad to kind of talk about how is identity and attack paths commingled.
Yeah, thanks, Jared. So a lot of you may have noticed that every time we talk about attack path management, we also talk about identity and vice versa. And the reason behind it, or the best way to understand the relationship between the two, is to look at things from the attacker's perspective. What do attackers want? What they're actually seeking to achieve in your environment? So what they actually want to do is impact the environment or steal data, Or if you're a red teamer rather than a real threat actor, you want to just demonstrate the ability to do so. And Matter broke it down into these different techniques under the impact category, or under the impact tactic in the Matter attack framework. And in every modern technological ecosystem, attackers always have to navigate some sort of an access control mechanism in order to actually achieve impact. It can be a security reference monitor on your operating system. It can be an IAM mechanism in some cloud platform. Whatever it is, there's always some access control mechanism that they need to navigate. Some people like to argue about this point, but I would insist that even if you exploit an unauthenticated remote code execution vulnerability, you're still implicitly navigating an access control mechanism to achieve impact. Now, these access control mechanisms must always handle two things: authentication and authorization. Authentication validates or answers the question, who is seeking to perform an action? And authorization answers the question of whether this principal, whether this subject is permitted or not to perform the specific action on the resource. Every access control mechanism is comprised of some sort of an access control list, and that list will have entries that usually look somewhat like this: a subject, an action, and a resource, and sometimes a decision, whether it is permitted or not. For example, we have an ACE here, an access control entry. Jared read is the action, and Andrew's email is the resource. And of course, it should be denied because Jared has no legitimate reason to read Andrew's emails. Now, in some cases, there are additional elements in an access control entry. For example, there could be additional conditions that must be met. For example, MFA or a compliant device, or time or location constraints. Some of these elements might be implicit rather than explicit in the access control entry. For example, if this ACE is attached to the resource, then the resource is implicit, or if it's attached to the subject, a policy attached to the subject, then the subject is implicit. Sometimes there's an allow by default or deny by default policy, and then the decision can be implicit. For example, everything is denied unless there is an entry allowing that access in the access control list. So we have an example here for an access control list. We have an help desk group that has admin access to my workstation. The domain admins group has full control over this domain group. As in any Active Directory environment, domain users can read everything, including all the different attributes of the domain admins group. And I have ownership of a production database. And we can take this access control list and depict it in the form of nodes and edges. And that will give us an access graph representing control over resources. And everything we see here represents authorization. There's nothing here that represents anything relating to authentication. It's all just authorization. On top of this, we can also add group memberships and role assignments. So we can see that Jared is a member of the domain admins group, and Andrew is a member of the help desk group. And if you look at this access graph from the defender's perspective, there's absolutely nothing wrong here. No security principle or security best practice is violated. There's nothing here that allows someone to gain access to anything that they're not legitimately permitted to access. From the attacker's perspective, things are a bit more complicated because attackers sometimes abuse elements outside of the access control model, outside of the access graph. Specifically, attackers often perform authentication-related attacks, such as an account takeover or all sorts of impersonation attacks, stealing tokens, dumping credentials, and so on. And the reason they do that is because they want to target the subject element in the access control entry. If they can take over the subject, of course, they can abuse the entry and then navigate the access control system.
Yeah, so we want to talk about this idea of identities at rest versus identities in transit. And this is a paradigm that we borrowed from data protection. So a lot of you are probably familiar with the concept of data at rest versus data in transit. And a long time ago, we realized that if you want to protect data from unauthorized access, one of the mechanisms that you use for that would be encryption. But we realized that the state of that data creates a different situation in how you apply that encryption. So for instance, if you have data sitting on a hard drive, data at rest, the way that you encrypt it is going to inherently be different, or the approach that you take is going to inherently be different than if you have data that's transferring over the wire, right? And so we have this idea that it's not just what you're trying to accomplish, which is data protection, right? Encryption of sensitive data, but it's about the state in which the data exists that we must also take into account. And we realize that this is not a new idea. It's a new framing of an old idea, which we all are kind of like generically familiar with, especially if you have like a red team background, which is the idea that identities themselves exist in two different states. You have the identity at rest, which is things like stored credentials, group memberships or role assignments, access policies tied to the identity object. These are, once you register a user account with the domain or with the IAM platform, you are creating an identity at rest. That identity has some sort of potential to perform some sort of access on different resources in the platform. But then we have identities in transit, and this is post authentication. After somebody has already authenticated, you start creating credentials, things like Kerberos tickets or access tokens in Windows environments, things like browser cookies or OAuth tokens when we're talking about cloud platforms, things like primary refresh tokens when we're talking about hybrid systems like Azure, for instance. And the way in which we deal with protecting these identities is really dependent upon the state that we find the identity in. And again, the identity at rest is a kind of potential access. The identity in transit represents realized access. Okay, so here's just like a graph that kind of shows what this looks like. So imagine that you have a user account over on the left-hand side. It's at rest, right? The general flow is that you're going to enter your password, your username and password. There's going to be some authentication that's performed. It's going to check whether or not you did indeed enter the correct password for the user account. And if you entered it correctly, it will create a logon session. This is maybe in like a Windows operating system context. It'll create a logon session, and now that identity is in transit. This creates a situation to where we can use tools like incognito to steal access tokens. We could use tools like Mimikatz to dump the clear text credential for that account. In other cases, if we enter the wrong password, we of course get access denied. Now there's a little bit of a case study that we'll get into here in a second, but again, credential theft is not exactly the same as stealing the password. So the general idea is that if I steal the password, I now have to re-authenticate, right? And so stealing the password is the equivalent of starting back from that identity at rest. From a different perspective, if I'm able to steal your access token or maybe steal your Kerberos ticket, I have the opportunity to take advantage of the fact that you've already authenticated, right? And once you've performed authentication, things like multi-factor authentication, things like password vaulting, things like conditional access, those are going to not apply in the same way that we expect them. We have a case study that we could look into, which is in 2024 there was this attack on Snowflake. This actually we'll talk about Open Graph. I created an Open Graph extension to look at kind of the access control model of Snowflake as a result of this incident, right? And so what they found is that there was a contractor who was acting as an administrator for several different organizations in their Snowflake tenant. And that single contractor was compromised, and the end result was that the attackers they got access to his browser cookies and his passwords for these different Snowflake tenants, and then they ended up selling those on kind of the dark web for other nefarious actors to access those Snowflake tenants. And there were several large companies that were affected by this. Now, Mandiant kind of worked with Snowflake to come up with some different recommendations about what we should do as a result of this. And I've listed the three major recommendations down here at the bottom. So one was enforce multi-factor authentication on all accounts, particularly kind of like privileged accounts. Set up network policy rules to allow authorized users and locations. So this would be essentially set it up to where you can't just browse to a corporate Snowflake tenant from the internet. You would need to be, say, on like a VPN or something similar. And so you're limiting access from that perspective. And the third is reset and rotate Snowflake credentials, right? So you've potentially been affected. Because you've been affected, you should kind of be proactive and rotate these credentials. One of the critiques of kind of these recommendations, well, I think these recommendations are great. I think they don't take into account this at rest versus in transit kind of dichotomy. What you'll notice is on this next slide, we've updated our graph here. So imagine that you have this application site that would be like your Snowflake tenant, and then you still have the same set of processes. What I've done is I've added those different interventions that were recommended by Snowflake and Mandiant, and we'll kind of analyze how that affects this relationship between at-rest identities and in-transit identities. I'm going to start from number one, which is over here on the right-hand side. That's multi-factor authentication. And so what you'll notice is that the flow is I enter the password, and then I'm going to be prompted for multi-factor authentication. Correct. Thank you for circling that, whoever's doing that. And that happens during the authentication process before the in-transit session is established. Similarly, we have the intervention number two, which is the network policy rules. This is before you even log in the first place. So can you even access the tenant? And so that's an important consideration. And then the third is the password rotation, which is kind of already built into our model. And what you'll notice is that all of these interventions occur or are focused on protecting the identity at rest. But we have information based on the way that this incident occurred that we know that the attacker had access to this contractor's computer. So we could imagine that the attacker already bypassed the network policy rules because the contractor had legitimate access to these Snowflake tenants. We know that, for instance, the attacker had access to the browser cookies that would facilitate access to the Snowflake tenant, which would bypass MFA and password authentication. And so in the actual implementation of this attack, the attackers ended up selling the at-rest, the passwords, the username and passwords, so the at-rest identity, but they had access to the in-transit identity. And so while these are good interventions that we should apply in general, and it will reduce kind of like the surface area, the risk in general for your different platforms, they are not holistic. And one of the general ideas is that we've over-indexed on protecting identities at rest, but the reality is that identities exist in general to be put in transit at some point. You don't just arbitrarily create user accounts in your different platforms and say nobody's ever going to use these things. What you do is you create user accounts because you intend to have an actual human being use that identity to perform some action, some business action at some point. And from an attacker's perspective, all they have to do is figure out where that identity exists in transit within an enterprise environment, for instance, and then they're able to bypass all of these different interventions that we put in place that are protecting identities at rest. All right, pass it back over to Alad.
Yeah, so what I want to do next is take this access graph and transform it into an attack path to show you what an attacker sees. So on my workstation, I am obviously logged on to my account. So what we can do is draw an has session edge representing my identity in transit and show this relationship between my workstation and my account. Another thing that we should take into consideration is that not all of the edges here actually represent control over an identity. They're not all abusable from the attacker's perspective. For example, domain users having read access to the domain admins group does not allow domain users to actually take over that group. So we should remove this edge from the attack graph. And after we've done that, we have an attack graph that actually represents all the paths that allow us to go from one node to the other. And if there is a path, it actually guarantees that an attacker traversing this path can actually take over whichever node they land on. And earlier I mentioned that there was nothing wrong with the access graph. It was all legit. There was no violation of any security principle or best practice. This is no longer the case. Now, if you look at it, you can see that Andrew, who is a member of the help desk group, has admin access to my workstation. And through that, Andrew can steal my session, steal my token or my cookie, whatever type of session it is, and then take over the production database that I own. So now, from the attacker's perspective, we can see that there's a bit more to the story, taking into consideration identities in transit. And there is an actual attack path, an actual risk that a defender might want to address. So this little ugly Venn diagram that I created earlier shows the relationship between the access graph and the attack graph. The access graph represents all the abusable and non-abusable access rights. And the attack graph represents those identity attacks that abuse the authentication side of the equation and the abusable access rights. So there's some overlap between the two graphs, but they're not quite the same, and none of them provides you with all the information that the other does. And each one of these graphs has value, has merit. An access graph is probably very valuable for a defender that wants to apply the least privilege principle, for example, and figure out what is the smallest set of permissions that someone might need or might have. And an attack graph is more valuable, obviously, for an attacker wanting to find a path from their initial access to the crown jewels, to the production database, or for a defender that wants to see what can an attacker actually do and what steps they might need to take to thwart actual attacks, or to identify the choke points that will allow them to eliminate the most attack paths with the least amount of effort.
Cool. And this kind of leads us to another idea, which we refer to as identity accumulation, or the identity snowball attack. And this is where, imagine that you're on that attack path that Elad was showing previously, and maybe you fished Andrew, and you became, as a result of having control of Andrew's identity, you were a member of the help desk group. And in some ways, the help desk group is quite privileged, right? So for instance, the help desk group often has admin control over computers. But there are certain elements or resources within the enterprise that the help desk group does not have access to. And a lot of times what we think of is, as you progress along your attack path, what's happening in practice is that you are switching from one identity to the next. So in the attack path that Elad just kind of walked through, you start as Andrew, and then you get access to Elad's computer, and then you steal Elad's identity. And a lot of times we like to think of this idea, so Andrew to help desk, to Elad's workstation, to Elad, the Elad user, and then we have a production database. And a lot of times what we like to think of is that we're switching from, for instance, in this case, Andrew's probably actually more privileged in the grand scheme of things than Elad is. And we like to think that we're switching from a more privileged principal to a less privileged principal. But in reality, what's happening is we're accumulating access. You don't lose control of Andrew just because you switched to Alad. In reality, what you're doing is you're becoming you're gaining the power of both, right? The privilege of both. You have the power of Andrew, whatever he can access, and you have the privilege of Alad, whatever he can access. And so now you have kind of like this aggregate aspect. And this is our little snowball right there, rolling down the hill. So as you roll down the hill, you're going to collect control over more identities, access to more resources, and eventually this all culminates in what we like to think of as like this tier 0 attack, which would give you access to the entire enterprise. So at this point, we'll pass it over to Andrew to go ahead and walk through an example of what this looks like from a real op.
For sure. So this is one of our first war stories. If you've read the State of Attack Path Management report that we just released in the last month, curious, show of like virtual hands, you raise your hand, just curious to see how many people actually have looked at it, downloaded it, kind of perused through it. If you have, this is basically one of our highlight reels of attack paths that we've conducted over the last 12-ish months that we wanted to highlight to show a lot of these, to bring a lot of these ideas, these theoretical concepts of identity accumulation, identities at rest and in transit, kind of and attack graphs to reality. So this is actual red team operation we did. I'm going to start, well, actually, before I start, I'm going to give you 10 seconds to kind of digest it without me talking and kind of look at what's going on here. Okay, so we'll start left to right and then kind of snake our way around. So as many of our red team operations do, we like to assume breach. We'll start with a compromised workstation, in this case, on-premises Active Directory, normal Windows workstation, unprivileged user, let's see, Alice and accounting. Now Alice, and this is the first kind of theoretical to reality concept here, has a session. So that's an identity in transit on this workstation, and that's our seated user. The next icon here, Alice. Happens to be, this is access rights, member of the domain users group in this Active Directory domain. So everyone in Active Directory domain, if you're familiar, is going to be a member of this group. That group was assigned enrollment rights in something called Active Directory Certificate Services for very, very common, the lowest level privilege escalation attack called ESC1. Now, this was a technique popularized by some of our researchers, Lee Christensen and Will Schroeder, back in 2021 with the certified pre-owned white paper, where they illustrated lots of different escalation and persistence opportunities leveraging this technology, ADCS. In this case, the main users group, effectively everyone in the domain, including Alice, had enrollment rights to basically create a certificate that would say impersonate any user they want. So I can enroll a certificate. This will be identity at rest that says, hey, I am, in this case, an SCCM admin. And SCCM, or misconfiguration manager, is essentially a management utility for enterprise networks, patches, configuration, software. If you compromise that, you can generally compromise anything you want in an on-premises environment. So that was the target. Went from the seated access user, Alice, enroll a certificate for this SCCM admin, then use that, kind of snaking around to the next line to target an SCCM management server. From there, we were able to compromise an actual admin workstation for, take a step back, the actual objective that we were trying to attempt. So on-prem environment, can you get access to the SaaS application? In this case, the SaaS application was a backup system, a cloud backup system. So as a means to an end, we use this configuration manager server to access an admin's workstation that had control of this cloud backup solution. And we're able to identify that based on Active Directory groups enumerated with SharpHound and visualizing that in BloodHound. See, hey, we know what the name of this cloud backup solution is. Can we find any evidence of what this might be in Active Directory and what users might be assigned permissions? Because otherwise, these users weren't privileged in Active Directory. So we pivot over to this workstation. We find here's another identity in transit. They have a session as a SaaS application user. In this case, the session is both Active Directory as well as a browser session. So we are able to dump cookies, as we talked about previously, as one of the things we like to do. Compromise identity in transit. It's already passed MFA claims, conditional access, get that cookie. use it in our own browser, log into the SaaS application, find out indeed that user is a super admin and we have full control over this application. So we've seen unprivileged Alice, identity accumulation up to a SCCM admin, to a workstation they shouldn't have control of, which happens to have this SaaS admin as well, who was probably not protected, not a member tier 0, wasn't domain admin, wasn't otherwise like super important or protected in the terms of Active Directory, but they were highly privileged in the SaaS application itself, this backup solution, which was our ultimate goal or one of our objectives for this red team exercise. And that takes us into, that's sort of a hybrid attack path, which I think Alad's going to cover next.
Yeah, just real quick before we move on, it's Andrew just touched on it, but you can't stomp it enough. There's often this disconnect between a human being, an individual's access in some third-party application and their access in the on-prem environment. And a lot of times what happens is we silo these different environments and we think, okay, well, this is just a normal domain user. They're not important, right? And so we're not going to we're going to treat them just like everybody else. We're not going to have some special security controls focused on that user account. But then what we realize is that on that computer, that individual is logging into the SaaS application as a super admin, and now we have full control over whatever that platform might be. And so there's this kind of like juxtaposition between what your on-prem privilege is versus what your overarching or your cloud privilege is. And that's where we find lots of problems that kind of leads into this hybrid concept.
Yeah, and it's becoming a lot more common nowadays. It's a pattern really, because nowadays more and more systems run in the cloud. And so for us as red teamers and for attackers to actually achieve their objectives, they often need to come up with some sort of a hybrid path to start on-prem and then somehow get to this SaaS application in the cloud, or maybe traverse different cloud applications or go from cloud to on-prem. It's becoming more and more common. And that is why just under a year ago, or about a year ago, we decided to introduce hybrid paths into BloodHound. And the most common hybrid path you'll find out there is between on-prem Active Directory and Entra ID, also known as Azure AD or Azure in general. Microsoft has been changing that over the years. So we represent these relationships in the form of two edges. Synced to Entra user represents a relationship between going from the on-prem AD user to the Entra user, and that requires that password hash synchronization or pass-through authentication or seamless single sign-on are enabled. In the other direction, we can also traverse from Entra to the AD user through the synced to AD user edge, which represents a password write back. So in other words, we can reset the password of an Entra user, and that will affect the on-prem user as well. And I'll be honest, until we introduced these hybrid paths, the BloodHound graph, at least on the Entra Azure side, was often a bit boring. There was no relationship between these two subgraphs. And while the Active Directory side of the graph was very rich and usually helped us find very juicy paths, on the Entra side, not always, but usually it wasn't as exciting. And once we got these hybrid paths in there, we started finding a lot of very interesting paths. So this is just a simple example from our lab showing that we can start with an Entra account who has the help desk administrator role, and then that allows resetting a password of a synced account, and then through that compromising an on-prem member of the domain admins group. But in the real world, in some of our enterprise customer environments, we saw quite elaborate paths going from on-prem Active Directory to a synchronized account in Entra. In there, there was some role assignment that allowed us to take over another account of another synchronized account going back to on-prem. Sometimes you could even cross forest boundaries of two completely separate forests that were synchronized to the same Entra tenant, and then sometimes even back to Entra from there again to compromise both on-prem and the tenant and the Entra tenant all together. There were quite interesting attack paths showing up all of a sudden. So it turned the graph into something very interesting. And one of the things we learned from that is that whenever we expand the BloodHound graph, and we'll talk about that a bit more later when we get to Open Graph, we should always make sure that we have at least one edge connecting the new elements, the new graph, the new technology to create those hybrid paths and show the true impact of compromising one environment. Now it can lead you to other environments as well.
All right, and that takes us to our next attack path or war story. In this case, another red team exercise, again, seeded access for an on-premises Windows workstation, laptop, etc. Allison accounting, could be Alad, could be Jared, could be anybody, low privilege. This case, we knew the target was AWS. So from an on-premises compromise, could you work your way through the network to actually get administrative access on the AWS accounts for this organization? So the first step, local privilege escalation. Again, we're just on this low privilege workstation. In this case, we combined a couple of techniques. One, which was NTLM relay, which we'll talk about coming up and how it integrates with BloodHound, as well as this technique called shadow credentials, which was popularized by Elad Shamir 2021. And I think Michael Grafnetter in 2019, I think he originally talked about it at Black Hat EU before that. But combining shadow credentials to set basically another identity in transit, something we know, like a password, in this case, a certificate, for this workstation computer account and a local NTLM relay, we were able to essentially gain system level access, full control of this workstation computer account. Why we did that? Well, we had already executed SharpHound and we'd seen what permissions are starting point. If we could get to the workstation computer account in that context, we could switch to it from the low privilege user, what could they do? In this case, it was a simple hop. We saw that they had write account restrictions, property or privilege on a server that had active domain administrator sessions. And to abuse that, we would abuse another technique called Kerberos resource-based constrained delegation, also popularized by Alad, which we should name this, like give you credit for this one, Alad, because this is your show. We use that, perform the RBCD attack for short, to compromise the server, and it has active domain administrator sessions. We can then steal the tokens for the domain admin. And then, all right, now we have full keys of the kingdom, full control of this on-premises Active Directory environment. From there, it's like choose your poison of the lateral movement techniques. In this case, we chose a flavor of WMI lateral movement to execute a mythic agent on one login, which is the AD Connect server. Why one login as well? And other earlier research in the environment, I believe it was on Compliments in this case, we saw where they federate identity through this identity as a service platform, one login, from AD to other cloud resources, in this case, AWS. So we knew if we could somehow compromise one login, AD Connect, we could find a path to AWS. It's our first time we ever seen it. We ended up reverse engineering the connector service for Active Directory, where it's essentially syncing users to the one login, and found that we could compromise the signing key. And in doing so, we could craft a token for any user we wanted to that was federated up to one login platform. So a little bit more research, internal investigation on who the AWS admins might be. So we found a user, we crafted a token, we logged in the one login portal. Lo and behold, we have access to 56 AWS accounts. So this is NTLM relay, identity accumulation, and a really cool hybrid attack path because it's on-prem to one cloud to another cloud provider.
One thing that's really worth kind of also sharing here is that Allot has this fantastic blog post called "The Security Principle Every Attacker Needs to Follow." I'll share it in the chat here in a second. But it's called the principle. What? Oh man, I just had a brain fart.
Clean source
The
principle.
clean source principle. And the idea is that you should understand the security dependencies of your systems, right? And this is an example to where there's a chain of security dependencies that allowed the attacker to go from Active Directory into AWS. And in this case, for instance, you have AWS, and a security dependency of AWS is one login, right? And so if I have control of the one login tenant, then I have control of your AWS tenant because of that security dependency. Similarly, because the AD Connect server lives in AD, there's a security dependency from Active Directory to one login. And so that means that if I have control of your Active Directory domain, I have control of your one login tenant, which then means that I have control over your AWS tenant. And so it's very important for us to understand the security dependencies that we've established, because a lot of times I don't think that we necessarily consider how all of these different systems interact with one another. And what we find, there's this big movement for like identity as the new perimeter and zero trust and all these different types of phrases that we hear. But what we find is that Active Directory is very often, very, 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 very often a security dependency of almost every system that organizations implement. And so if I get control of your Active Directory, maybe it's not mapped in BloodHound, maybe it's not obvious, but if I have control and I spend enough time kind of like looking around, trying to figure out what's going on, I will be able to find a path that allows me to escalate into some other platform. And it's a terrifying thing, to be honest.
Yeah. We didn't really plan to talk about it in this webinar, but I would say that if you look at the attack graph, every traversable edge in the attack graph actually represents control, and control is just a nicer word or a simpler way to describe a security dependency between two components of the system. All right, so Andrew mentioned a couple of different NTLM relay attacks in this attack path. We actually did another webinar about NTLM attacks earlier this year, and we also published a detailed blog post and a white paper going into that in a lot of detail. So I'm not gonna give you the drill down into NTLM relay here. Don't worry, we're not gonna repeat that. But what I do wanna highlight is that when attackers want to perform an NTLM relay attack, they actually need to collect quite a bit of information, collect and correlate quite a bit of information, because a lot goes into that. So for example, if you want to perform an NTLM relay attack to an SMB server, you need to figure out which hosts don't require SMB signing. There are different tools that can help you collect that. NetExec is one of them. Out of all these hosts, you also need to identify which hosts are interesting. What would make a host interesting? Probably a logged on user with an identity in transit. And that logged on user should have access to something you're actually interested in. You should open a path for you to actually reach your objectives as an attacker or a red teamer. You can identify such interesting hosts with BloodHound. Another thing that you need to do is find computer accounts that have local admin access on the machine that doesn't have SMB signing required. The reason for that is that we're going to usually we combine NTLM relay with authentication coercion, and what you actually coerce is computer account authentication. When you perform an NTLM relay attack, what you're actually bypassing is authentication. But after you authenticate, you need to also make sure that your new session, this identity in transit that you now have, can actually perform some interesting action. So that's the authorization side of things. And that's also something that we can identify with BloodHound. And last but not least is that we need to make sure that the computer where this computer account lives permits outbound NTLM authentication. While it's technically something that you can block, it's extremely rare to find any hosts with outbound NTLM disabled. But still, we need to make sure that it's not going to block the NTLM relay attack. And after the attackers collect all this information with different tools, and they make different lists, they then need to cross all these lists, and the intersection of all these lists is what they can actually target in an NTLM relay attack. The same idea applies when you relay to LDAP. You need to identify at least one vulnerable DC that doesn't require either LDAP signing or LDAP channel binding. You can identify that with LDAP relay scan. And you need to identify a client that you can coerce and relay to LDAP that requires that the web client service is running. There are other tools that help collect that. As before, you need to make sure that the host you're about to compromise is actually interesting. BloodHound can help you with that. And as before, outbound NTLM allowed is a requirement. And here again, the attackers need to make different lists, intersect those lists, and that's what they can actually target. We also have NTLM relay attacks to ADCS web enrollment endpoints. That's the infamous escalation 8. Here we have even more requirements and more things that we need to collect and cross. I didn't even have enough space on the slide here to make an ugly Venn diagram. But here too, you can see that most of the information, especially that the information relates to the authorization side of things, is already present in BloodHound. And there is some additional information that we need to collect outside of BloodHound to figure out what's actually viable. So what we decided to do, instead of making lists and intersecting them, we wanted to help attackers think in graphs once again, even when it comes to NTLM relay attacks. So we introduced some new capabilities to SharpHound to collect all the information required instead of using different tools to collect bits and pieces from different places. And then we crossed all that information to create new edges that represent authentication coercion and NTLM relay attacks to vulnerable hosts. And we present in BloodHound only the viable, what we know for sure is viable, as edges, helping attackers, again, think in graphs, run pathfinding queries, and identify vulnerable servers. You'll notice that these edge names combine two things, coercion and relay. And again, that's because what we have here is an actual transition from an identity at rest to in transit, or basically we need to trick a computer to establish a session to whatever it is that we want to target, and then we can hijack this session and do whatever it is that the computer is allowed to do. So we move from authentication to authorization. Another interesting thing about authentication coercion attacks, specifically computer account authentication coercion, is that all authenticated users can actually perform these coercion attacks. So all these new edges always take you from authenticated users, pretty much anyone, to a computer that you can compromise. So you go from 0 to hero in each one of these cases, especially if the target computer is in tier 0, let's say a domain controller, and then the entire environment, the entire AD side of things at least, is compromised. I have some examples here, so we can see how we can go from authenticated users to a domain controller. through the coerce and relay NTLM to SMB edge. We have another example here with LDAP. Authenticated users can coerce and relay to a domain controller, and here we can see which computer it is that we need that needs to act as our coercion victim in this scenario in order to have a successful relay from this client to this server and compromise the server. Same thing applies here with ADCS. Authenticated user can coerce and relay to compromise some other client host in the environment. And if we look at what we call the composition view, it shows us all the moving parts. When it comes to ADCS, there are a lot of moving parts. It involves enrolling a template in this machine certificate template published to this CA. This CA is an enterprise CA for the domain. It is permitted, it is trusted for anti-authentication, meaning that you can use it for Kerberos authentication. So it tells the attacker what it is exactly that it needs to do, which certificate template to target, which CA to enroll with, and for defenders, it shows the defenders which certificate templates are vulnerable, which CAs are vulnerable. There are different strategies or approaches for mitigating this depending on the environment, but it gives them the view that they need to see all the components involved so that they can make the decision on what's the best approach for fixing this.
All right, now we'll talk about Open Graph, and this is probably the thing that has me most excited about the future of BloodHound. Now, a lot of you that are familiar with BloodHound know that we've traditionally been focused on the Microsoft ecosystem. We started with Active Directory, then moved into Azure, and then Alad just talked about ADCS and NTLM. And the reason why we focused on Microsoft products was because this, as I just mentioned, it's kind of the backbone of most organizations' identity infrastructure. Almost every organization has an Active Directory domain, and as we just mentioned, Active Directory domains are often the place, it's often a security dependency of all these other platforms. And for no other reason than your Active Directory domain is the place where your identities are in transit, right? So like when you log into corporate systems, you're often doing so from an Active Directory joined computer, right? And so that means that if I have control of your Active Directory domain, then I have control of those in-transit identities, and therefore I have access to all your different systems. Okay. Now, okay, come on. Okay. Now we had this issue though that as people began to, BloodHound is an open source product or project, and as people began to expand the graph, they found it very difficult to integrate their expansions into BloodHound. This was true for our research and development team. This is also true for community contributions. So here's an example. KubeHound was created by the Datadog team, and this was to show Kubernetes related attack paths. Over time, they realized that, hey, this isn't going to be something that we could easily just put into BloodHound. So we're going to actually create our own standalone product. And there's a couple problems with that. One is that these researchers who actually care about attack paths and understanding risk that's posed in these different platforms now have to look at engineering problems. Like how do I build a UI that users can use? How do I make sure that I manage all the data on the back end? And these are relatively big problems that somebody that is a researcher doesn't really want to have to deal with. The other problem is that you lose that connection, those hybrid paths between platforms. And as we mentioned, that's where we find that there's the most value, is kind of understanding the security dependency architecture between all these different systems that we're using in our businesses. Okay. So Open Graph allows us to kind of build an arbitrary representation of a model and integrate new attack paths from different platforms, right? So it's this idea that we are committed to building this extensible platform that is going to facilitate attack path research and validation. It allows us to look at attack paths across any platform. It allows us to interact with the community and have the community build their own extensions, which we'll highlight a few of those already. And you could do this, like most importantly, without modifying any code. Just to give an idea, I built a 1Password, which I think I have a screenshot of, 1Password extension in 2.5 hours. Now, it's not as complete as, say, like the Active Directory components of BloodHound, but really just to kind of give you an idea of like the beginning to end, understanding, like it took me 2.5 hours to write the PowerShell code, to collect information, to build an understanding of what the access control model of 1Password looked like, and to actually get it integrated into this Open Graph schema to upload into BloodHound. So it's like a really, really fast turnaround for some of these smaller, kind of more point products to really get an understanding of like what the exposure looks like. Okay. So again, with BloodHound 8.0, that's when we released Open Graph, and that allows us to ingest arbitrary nodes and edges into BloodHound. It allows you to make changes to existing objects, so you can like add properties to an Active Directory computer, for instance. It allows you to do ingestion based off name. We used to require that everybody would ingest based off of the ID, so like a SID for a Active Directory user, for instance. But now you can just give it the name, and it will figure out how to manage that. And that's been a kind of a big problem for people integrating information into the BloodHound graph in the past. It allows us to define custom icons and backgrounds and colors for these different node types. That's actually what I find to be the hardest part of Open Graph, is choosing your color palette for your new extension. And it allows you to delete data based on the identified type. So if I'm building like that 1Password hound example, I can tag all of my 1Password related nodes and edges as if they exist within this 1Password kind of ecosystem. And then later on, I can say, I want to delete not all of my data in my database, but only this the 1Password related data. So it kind of gives you that granular control over deleting information from your database. You can do Cipher queries to query that information, and then all the properties are going to be kind of shown. JD, one of our, a lot of you might know him as Walter Legowski. He is a maestro when it comes to visualizations, so I have to give him credit on this. But he went through and built out kind of this visualization to show what like an Open Graph payload looks like. And so here we have this relationship. I call it like an attack path segment between Bob and Alice. And so it's just Bob is a person node, and Alice is a person node, and Bob knows Alice. And so the way that we represent this is on the left, we have the person node being defined. We have an ID. This is an arbitrary ID. Sometimes your actual system will give you an ID like a SID or like a GUID that's associated with the actual resource. We have kinds that we define. That's like the label, the type of node that we're dealing with, in this case, a person. And then you have arbitrary properties like Bob, his age is 21, so on and so forth. You do the same thing with Alice, and then you create like an array of nodes that you want to ingest. And then you need to define your edges. And so edges are going to be, what is the type of edge? In this case, nose, and that's going to be the label for the edge. And then you would give it a start and like a start and an end node. And so in this case, you can say, the node that is represented by the ID 123, which is, as we see over here, is Bob, is going to have a nose edge to Alice, and you can match by either ID or by name. So it's just kind of giving you an idea of what this looks like. I wanted to touch on, we released Open Graph a few weeks ago, right before Black Hat, and we had a couple Open Graph extensions that came out of the box that some of our team had built. But we've had just a tremendous amount of interest and support, and we've even had some community contributions. So probably the Open Graph extension that is the most robust and kind of like built out is MS SQL Hound, which was made by Chris Thompson on our research team. And so this is representing your ability to understand MS SQL attack paths inside of databases, between databases, that kind of thing. So it's really cool. This actually builds a foundation for attack paths in SCCM. I was recently reading some information about attacking ADFS servers, and you find that ADFS servers are built on MS SQL, and so there's MS SQL kind of serves as this foundation for tons of different components of our Active Directory infrastructure, and you'll see it all over the place. And it's kind of this missing link that we have. Okay, I created GitHound, which is allowing us to look at GitHub Enterprise, and so you can start to say things like who has access to what GitHub repository, and you can start to map that out. A really cool aspect of this is that if you're using single sign-on for GitHub, then you're able to link your GitHub user to your, say, Azure user that's being used for single sign-on. We've also set it up with, a lot of you might have seen that Andy Robbins did a post in the BloodHound Slack talking about kind of teasing Ping One Hound. So Ping Identity as another IDP, kind of like Okta or OneLogin. And Andy is working on building out an attack graph extension, an open graph extension for Ping One as well. And so we've played around with using Ping One as SSO for our GitHub account as well. And so we can start to ask who has the ability to write to this repository, and we kind of go into that. So far, we've had, it's been really, really awesome. It's been a lot of work as a result of it, but we've had 6 total contributors. So we've had people submitting issues where they've had issues with collection and kind of helping with recommendations on that. We've also had people that are actually making pull requests to kind of make GitHound a more robust solution. So that's been really awesome. We at Black Hat, Lance Kane and Dan Meyer really had a presentation on kind of like attack primitives in Jamf, which is kind of like a system for managing your macOS endpoints. And along with kind of that presentation, they released JamfHound. And so this is a way to visualize attack paths in your managed macOS environment. And so that's pretty awesome. It's kind of an ability for us to move into a different area with the attack path outside of like the Microsoft ecosystem. Now we have a couple community contributions. The first like full featured community contribution was Ansible Hound. And so this was a way to visualize your Ansible Tower deployment for like deploying your CI/CD pipeline and you're managing the deployment of different resources. And we also have vCenter Hound, which was created by a gentleman named Moore David. And this is allowing us to, this is like really, really cool because we're talking about ESXi. And in the news recently, there's been lots of focus from threat actors on targeting vCenter deployments. So ESXi virtualization deployments. And what we find is that, and I don't think it's integrated into the model quite yet, but it's on its roadmap, is a lot of organizations use Active Directory to manage authentication or manage users in vCenter deployments. And so if you have control of an Active Directory domain, you might have control over a vCenter cluster. And then they're also managing, literally hosting Active Directory computers, say like domain controllers, for instance, in their vCenter cluster. And so this is this hybrid attack path kind of approach, right? I might have access to a user that has control over your vCenter cluster. That's not a domain admin, but that user has control of a VM, which happens to be your domain controller. Now they have the equivalent of physical access to your domain controller, which is just a new approach to thinking about these attack paths. So it's a really cool contribution from that perspective. All right. We also have this Open Graph library. So we really want to get the community thinking about like what are the different platforms or capabilities that they want to see in Open Graph, and we're trying to promote it as you go. So in this Open Graph library, which is in the BloodHound documentation, we are highlighting any of the Open Graph extensions that we're aware of. And so Phil, if you're working on an Open Graph extension, please feel free to let us know, and we'll try to get it added to the library. You'll notice that as we list out the different extensions, we'll have like a SpectreOps logo, which represents that that was built in-house by a SpectreOps researcher, or we'll have kind of like a little a group of people that represents that that's a community contribution. There are different support levels that will be coming in the future. So right now, kind of it's like use at your own risk, I would say. We recommend probably giving these a shot in your BloodHound Community Edition, self-hosted deployment first before you try to look at integrating it into your BloodHound Enterprise deployment, just to make sure you're getting what you expect. But generally speaking, we want to enable you to find new extensions to expand your understanding of kind of like what your attack path landscape looks like. We want you to contribute back to the community through these Open Graph extensions. We want to feature you, so we want to show the community the work that you've done, and then we want to evolve and make it better over time. We even encourage people to don't just because I've looked at GitHub doesn't mean that I have the authoritative approach to mapping attack paths in GitHub. It's 100% okay for other people to look at that from a different perspective, and maybe we'll learn from each other by both of us looking at the same technology. All right. And so that kind of caps off with this Open Graph Community Incentive Program. So we want people contributing to Open Graph and building out the kind of like the BloodHound graph in the areas that they find useful. One of the things that, for instance, Andrew's talking about how they interacted with this SaaS application as part of their attack. We can definitely envision a future where red teamers, as they are conducting an op, are actually building kind of like a just-in-time Open Graph extension that allows them to visualize the attack path for the platform that they're interacting with. Kind of get that visually so that they can either represent that to their customer or represent that to their team members so that they understand what are the different resources that we have access to. Maybe I'm in Confluence. I have access to Confluence. The question is what resources within Confluence, what files and documents do I have access to? And you want to see that. So we want to incentivize that. So if you submit a write-up or a talk proposal or real-world research that's related to Open Graph, we are reserving, I think it's like 10 opportunities for people to either get some sort of financial bonus or the ability to attend our SoCon event in 2026. So that would be a ticket to the event, a flight, and a hotel to attend the event and potentially even present on their research and their Open Graph extension. So we're really hoping to get the community involved and kind of build this out to where we're sharing that capability with the overarching community so other people can understand the risk that's posed by the interconnectedness of all these different platforms. All right. And so at this point, we'll open up for questions. We probably have a few minutes for questions. But I also want to highlight, we have quite a few different events or resources that we want to make available to you. For instance, in the top center there is that BloodHound Open Graph, BHOG as we affectionately named it, library. We also have the State of APM report that's available for you to download and kind of check out and read about some more detail of some of the different topics that we touched on today. We also have that Open Graph incentive program that's available for you to check out if you're thinking about building out an Open Graph extension for some platform out there. Happy to answer any questions for anybody.
Yeah, so if you want to ask questions, we have the Q&A function here on Zoom. Feel free to ask whatever you have on your mind. There are no questions. I guess we can wrap up.
Okay, cool. Well, thank you everybody for attending. Hope to hear from you in the future, and thank you for joining us.